Hi everyone, this is Wen. Today I'm going to use this video to explain a little bit about the coding about the Webbench implementation on the NNWorkflow in DATAVIEW. So basically we're adding the capability of running the deep learning neural network in DATAVIEW. Firstly, we have implemented that in the Java API side. So we are able to construct in the Eclipse and concatenate any NN task into an NN workflow and run them in the GPU services. For example, we have the local GPU, we have the GPU cluster, so we have different settings, or we have different configurations to run a single NN workflow. And later, we are working on to implement the Webbench version of the NNWorkflow. So as you can see right now, we have one of the NNWorkflow appear in the browser. So this is an NNWorkflow which has 4 layers, which is a linear, ReLU, linear, and sigmoid. So from this video, I'm going to delve a little bit into the code, how we'll realize these all the package in the browser. But of course, I may not be able to cover all of them, but I will list out the most important thing that you may interested in. So one more reminder is that all the files, or for example like the task folder and the workflows folder, which is retrieved from the Dropbox. As you can see here, we have the Dropbox button, and you're able to input your private key that is able to retrieve from the Dropbox website. You're able to input that into, and then we're able to retrieve the files in your Dropbox folder. As you can see on the left hand side panel, we also retrieve the files like the input data file, output data file. So like this, we are able to get the data from your Dropbox account. So let's get into the code directly. So this is Eclipse, and we have the DATAVIEW latest project in this panel. And I think there's something we have to clarify at the beginning. So all the layouts have been written into this workflow.jsp because we use a JSP and a servlet, Java servlet, to realize the Webbench of the DATAVIEW version. So here you are able to see many layouts has been defined into this workflow.jsp. Also, we have a lot of JavaScript code which is able to dynamically show up like the pop-up window or dialog, or we're going to write some scripts that is able to call the AJAX, which is able to call the backend servlets in a synchronized way. So that is how we do. And on the backend, we have the mediator.java to work as a servlet for this Webbench version. So let's firstly look at the JavaScript code. So after we have the right panel that's appear, so this have been working fine in the previous version, so all the files will be downloaded in the right panel. You're able to see all the tasks and all the workflows. So for example, you are able to drag and draw any task into this browser, and here I draw one of the pre-saved workflow that is called the breast cancer NNWorkflow 2, and this is looking like this. So whenever we draw this, we drag this, we are able to trigger one method in the JavaScript. So that is a method resides in the MX graph related code. So in this class, we are going to have many methods. For example, like make port draggable, make task draggable, and make the workflow draggable. So this is a method will be called initially. I think maybe at the rendering of the browser, this method will be called. For example, like the make task draggable, and here we're going to return one of the function call that is being able to be parsed as a parameter. For example, like here is a parameter func to drag task, and this one will be called later. So whenever we drag the actual task into the browser, this method will be called, but this one will be passed as a parameter ahead of time. So the only thing that is changed here is because we have to differentiate the NNWorkflow task and the regular task. So for example, like here, we need to differentiate the linear layer. The linear layer, which is different from the regular tasks, because we're going to have the input parameters. And the way we're going to encode the input parameter is to put the name, put the specification into the file name. So that is how we get the substring over here to get the actual specification from the file name. So if we get that is a linear layer, we're going to also render that into the cell, which was when we get insert vertex, we're going to put the specification into. For example, like here, we're going to have the label and the specification. The label is a hidden div, which is not being able to see from the browser, but the specification will be showed up. As you can see over here, the website, we're going to show, for example, like 3 times 1. Whenever you drag, this one will be automatically parsed from its name. So you can see this one is parsed from this linear 3 times 1, and if you drag this into, and this one will appear in the middle of the vertex. So that is how we parse the specification from the file name to the actual visual in vertex. So let's get back to the code, and after that we're going to parse all of these information into the translator or the XML. So I use a XML parser and the MX graph to scientific workflow translator. So I use all of them. I didn't change anything. Initially I think maybe we need to change something, but after I read the code and do some experiment, I found out they are sufficient to use to feed our need for the NNWorkflow. So after that, we're going to just trigger whenever we call the NNWorkflow, we are going to say wrong, and there will be a pop-up. So I think this one may be not valid. So let's rerun it again. So let's run as on server. So I have this single, so I think I will save, because I just did some documentation on this, and hopefully when you read the code this will be more clear. Okay, so let's log in. As you can see over here, I can do some demo. For example, like the linear layer 3 times 1, if you drag in, and this one will automatically show up in the middle, which is a specification of this particular linear layer. And we also able to track the workflows. Whenever you run a workflow, if that is not saved, and we will pop up a window, and then you are able to save that workflow in your Dropbox folder, which is a workflow folder. And next time whenever you open the browser, you're able to drag this again very easily back to the browser. So as you can see, this is a workflow, and when we click the run method, we're going to able to choose one of the environment. So we're going to choose the local NVIDIA GPU, so we can see submit, and this is run. So when we go back to the Eclipse, you can see it's running actually. Let's give it some time to run, and meanwhile we will continue to introduce our code. So when we call this, and the code is actually, I think, in the use Webbench. Over here we have one method which is workflow run configuration detail, and here we specify a new category which is a run NNWorkflow on a local NVIDIA GPU. So this one is going to trigger an action in the mediator.java, which is a local GPU run NNWorkflow, and give it some parameters as well. And we use a AJAX call to trigger this kind of asynchronous handling or synchronized call to the backend mediator.java. So let's take a look at the mediator.java. For mediator.java, the method we're going to call is this one, the local GPU run NNWorkflow. So this one is we're going to have a HTTP serverless response, and basically this one will be able to able to get a specification from the browser as a document. So because you can see we are in a tree, this is a tree format. We have to parse this tree format into a document file. So this has been successfully been done by, as I mentioned previously, the translator that had been pre-written by some other students, and this is sufficient to work, so I reuse this one directly. So after that, we are able to get all the information in a document in format. So after that, we're going to feed this document into the generic NNWorkflow class. This is a new class I read specifically for this NNWorkflow Webbench version. So let's look at this one. So the core of this file is a design method. So as you can see, the design method is like a executor. So basically we have to download something. We have to download, for example, the input dataset, and we also have to download some DLLs, which is necessary for the local GPU to run. Because I realized that in the web version, the local working directory is changed to, for example, on the Windows, it's changed to the changed to the Windows /system32. So that is a folder which is a working directory of the Webbench. That is for sure is not the project directory. So I think that is also one of the reasons we are using the temp folder to recite all the files and all the outputs in our local machine. So that is why we also download these files into our temp folder. Here we download the input dataset, we download the DLLs, and later we're going to add some output files as well. Further, we are going to concatenate or construct a workflow from the specification we get from the translator. So basically what we are going to do is we get some XML, because XML is not sorted. So whenever you get something and it's not sorted, we have to find out the first task. That is very important for the new network workflow, because if the order is wrong and is changed, the result will be affected severely. So the first thing is we are going to find out the first task, which does not have the input port. Which does not file in its input port. So that is where we find out the first task, and then we are able to trace the output port, and then we can concatenate all the task into an NNWorkflow. So that is a logic behind this part of code. And also later, after we concatenate an NNWorkflow, we are going to call the sequential method, which is quite similar to the API version, and we're going to wrap up this design method. So if we go back to the local GPU run workflows, when we trigger this generic NNWorkflow with this specification and token, because we have to upload or download the files from Dropbox, and then we will call the design method as we just discussed, and then we will parse this generic workflow into the NNWorkflow trainer, which is a local GPU that is able to be run. So maybe we can take a look at this one as well. So basically, we're going to trigger one of the GPU resource management with a specification and API repository. So this one is extends the NNWorkflow trainer. So this one is basically NNWorkflow trainer is able to parse all the NNWorkflow specification into GPU recognizable specifications, and in its child class, for example like the local GPU, we are able to specify one of the GPU resource management that is targeted at one of the GPU resources, as well as one of the execution plan, for example like the regular train and test or the cross validation. So let's go back, and we're going to specify the output file, and we have a add symbol with some hash code to make that unique, even though you run multiple times, and you can have unique outputs from each other. So we get this, and we will call the trainer.train method. That one is got from the NNWorkflow trainer local GPU, and the result will be returned as a string that is in the JSON format. Also, we can print that out, and we will upload that into the Dropbox again. So after that, you will be able to see. So let's get a look at the result. So over here, you can see this is a result of the final execution of this NNWorkflow. We have the device information, which is the device that we have run this NNWorkflow. You can see I have a RTX 2080. There is some specification follow. Also, we have layer architecture. So what kind of layer architecture we use for the this NNWorkflow training or testing, and we have the safe model that is returned from the CUDA side, and we have the every layers, we have bias, we have weights, etc. So this is the information we will be get from the return JSON. And also we have the training cost at maybe every 100 epochs. For example, like you can see at 0 epoch we have 0.49, and at 100 epoch we have 0.41. So that means the cost is decreased. So there is one things to keep in mind. The cost is the average loss in certain number of epochs, or certain number of data sets, but the loss is only for a specific data set, maybe a row. You have a loss, but we will average that loss, so that is called the cost. So you can see we have maybe 1,000 epochs, and we will have 10 cost will be logged into this return JSON file. So as you can see, I can open the maybe I can not open it now, but in my Dropbox, for sure the output file has already been saved there. So that is one thing we will reuse in the future when we have the executor. We will maybe read from that file, and we will be able to retrieve the weights, bias, and architecture, and we can reuse without the training to maybe incorporate into a larger workflow in the future. So this is something for the this method, which is a local GPU run workflows. And there's something to worth to mention as well, because when we click this button to see the result, actually this is triggered from one of the method in the use bench. I think the method name is view data product value, and this one will also be called from by an action that is in mediator.java, which is a get data, and by a AJAX call. So if we go to mediator.java and see this method, I just do a little change on the get data method, because previously I think we set a limit, maybe 1024. Maybe that is a number in previous version, but as we are going to return a lot more information from the NNWorkflow, so I just to relax this limit a little bit more, so that we are able to see more information from the browser. So that is one more change to make this available in the current version. So yeah, I think that's maybe pretty much about this video, and hopefully you can understand better about how our Webbench version of DATAView and work on the NNWorkflow. That is how it works. So hopefully you enjoy this video, and maybe until next time, happy coding. Thank you for your time.